So, this was something else that I was thinking about for augmenters from Tech Ingredients. It's apparently what they're called for jet engines that have their exhaust leading into something. You know, where Bernoulli's principle maybe comes into play. And I left a comment, right, on their video. And I think the point here is that heat does expand things and allows for acceleration. Depending on how you allow for acceleration and combination with more air, that makes it more efficient. But more mass does not necessarily equal better, even if you capture it more efficiently, as of course the other side of that is it still has to be accelerating enough to give a force proportional enough for it to matter to whatever the engine is and whatever it's attached to. So the standard rule of thumb for any person out there is typically the best option is to get it to be a mass equivalent to the same speed that you want to travel in the opposite direction. Now, granted, gas isn't really that great at doing that. So what we do is we make it accelerate faster, right? But there's that fine limit, and however you tune it, you can get a little bit more from that exhaust. It's usually better to put it into the actual design from the start versus trying to make it attached afterwards, which is usually how to get across the basic kind of like barrier informational understanding gap that typically most people have for that kind of stuff. The other side of it is let's throw that out there, space, then you don't need to. It doesn't. Any amount of thrust of any sort captured as efficiently as possible gives you the greatest results. So it's a catch-22, and that's why it's drag versus, otherwise known as friction. Some degree of resistance to travel of motion forward versus, that kind of thing, happening, and that's why you try and balance it out. Right now, if you add in air, of course, yes, while it does cool it off, depending on how you do it, you can gain more efficiency, especially if you can create some nice vortices. You can create a little bit of lowered pressure and you can have it mix more evenly. You can usually get it to then funnel and accelerate yet once more, and then as it tries to continue doing this vortex, it happens to effectively reorientate itself to an elongated pattern. That is why a lot of these nozzle areas happen to have a large amount of these little stators that don't go to a hub and are teardrop shaped. They effectively diverge, off with the center that travels faster, with these outsides that try and get squeezed to being faster as well, with a leading edge plug of air that's a good thing to actually have because that's higher compression. And if you happen to use that to your advantage with a little bit of extra fuel, you then manage to get a reignition that is more efficient than average. You also don't need to do that because if you happen to place a little bit of electricity there, if there's any nitrogen oxides within inside of your system, you might just be able to, depending on the speed and the rate at which it is, effectively either climbing or descending can give you greater amounts of air pressure and those nitrogen oxides that you can then use with a little bit of electricity, which is effectively a spark plug here, to produce a explosive decomposition of those gases, making a cleaner exhaust for a little bit of electricity. That, of course, still introduces that heat, which is fine. We wanted the heat anyways. But it also reintroduces an expansion, which, of course, gives us greater acceleration. So the caveat being the higher Q value, meaning energy efficiency value here, of that thrust to mass moving one other direction, whatever way it is effectively helped by and mitigated by that amount of mass and its acceleration proportional to your amount of mass and your amount of resistance and accelerating in the opposite direction. There's a bunch of stupid fancy numbers and letters to that, but that's all that is trying to tell you. So don't think it's that intimidating. It's really actually pretty simple stuff. All right, have a good one. Bye.